Hello students, welcome to my lecture on computer graphics. I am Shravani Kundu, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. Today, I will discuss the polygon filling algorithm. Now here you can see there is a polygon of triangular shape. And as you know that to fill the polygon, we can select any color, and if I click on it, the polygon will be filled up by the color. So apparently it seems that it is very easy to fill the polygon. So there are different drawing algorithm, drawing programs, applications. Through this application, we can form different types of polygon, and we can fill up the polygon as per our requirement. Now in this class, I will discuss how to write down the code to which will fill up the polygon. So instead of just selecting a color and clicking on the polygon, what I will teach you, you can write your code, and using that code, you can fill up any polygon which will be designed by you or drawn by you. Okay. So there are basically two approaches for polygon filling. So this polygon filling is sometimes called the area filling algorithm. So the first approach to fill the area is to find out the scan line. So we will find out some lines which is parallel to x-axis, and we will draw the line with some colors, and we will repeatedly draw the line which are very consecutive to each other, and that means the difference between two y value for the successive lines is 1, and we will draw the line using the color, and in this way we will fill up the shape. So this type of filling strategy is called the scan line filling algorithm. Okay, so basically there are polygon filling algorithms are of two types. The first one is scan line polygon filling algorithm. Okay, so this is two types of polygon filling algorithm. The first one is called the scan line polygon filling algorithm. Okay, and the second approach is something different. What we will do in this second approach, we will find out a point inside the polygon, and we will try to fill up all the points around which is nearest to it, and we will repeat the same thing till we reach to the boundary. Okay, so this is the another approach to fill the polygon. Okay, so this type of filling algorithm is sometimes called the boundary filling algorithm. So this is called the boundary filling algorithm. So what I am discussing, so consider you have a shape like this one. Okay, so you have a polygon like this one. So in case of scanline polygon filling algorithm, so what we will do, we will initially draw some line which are parallel to x-axis. So some lines will be drawn and which are parallel to x-axis. So suppose, so let me first draw the axes, then it will be easy for you to understand. So I will draw the line. Okay. So this is my x-axis, and this is my y-axis. Fine. So what we will do now, we will take some lines which are parallel to x-axis. So it will be something like that. So consider this is a line which is parallel to x-axis, and what we will do now, we will color only, so this is, first let me draw the line. So this is a line which is parallel to x-axis. Fine. Now what we have to do, we only color only that portion of the line which is inside the polygon. So you can see over here that in this is a line which is parallel to x-axis for some value of c. So consider the distance is c. So we can consider the equation of the line is y equals to c. So for this particular line, so what we have done, we have just colored the portion of the line which is inside the polygon. So in the same way, again we will draw another line which is y equals to c plus 1. So definitely it will be next to the next line after this, and these two lines y equals to c plus 1 and y equals to c, these two lines are very consecutive. And in this way, if you draw another line, so as I'm showing you over here, so I'm showing you the line, but in this case, the line is not that much consecutive, otherwise you can't understand. So what I will do, I will draw a line. So I assume that this is a line. This is a line for which the this distance, that means the distance from here to here is c plus 1. Assume. But here the line y equals to c and y equals to c plus 1 is very nearest to each other. That is the next pixel, just the next pixel along the y direction. So you cannot distinguish that there will not be a single gap between these two lines. So here for your understanding purpose, I drawn these two lines and there is a minimum gap between these two lines. So what we will do again, another line will be drawn by with the y value c plus 1, and what we will do, again we will color only that portion of the line which is inside the polygon. So here you can see we haven't colored the entire line. We have colored only some portion of the line which is the inside the polygon. So in this way, if we successively drawn all the lines which is parallel to x-axis, and if I successively colored it only those portion of the line which is inside the polygon, and in this way we can color the entire polygon. So this type of polygon filling algorithm is called the scanline polygon filling algorithm. So those lines which we are drawing, which are parallel to x-axis, so those lines are called basically scan line. Okay. Now there is another type of algorithm, another approach to fill the polygon, which is called the boundary filling algorithm. Now for the boundary filling algorithm, I am taking the basic shape. Consider this shape, this triangular shape. I am taking this one. So what we will do over here, so here consider we will take any point which is inside the polygon. So we assume that we have taken a point P which is inside the polygon. Okay. So after taking the point P, what we will do, we will take some points which is nearest to the point P. That means which are the neighbors of the point P. So it will be like this one. So if you just observe it, so as I am explaining, so this is the grid structure, this is a pixel structure. Okay. So this is my pixel structure. That's all. So consider this is point P. So the cell which I filled by color red. So this is just a point, a dot, and as I already discussed you that the pixel is not the circular in shape, it is the square or rectangular in shape. So here you can consider that this is a point P. Okay, so this is the point P. Now what is the approach over here? While we will take the point P, we will find out all the nearest neighbors. So who are the nearest neighbors? So those are the nearest neighbor. Now we will check whether those neighbors are inside the polygons or not. So if all the neighbors are inside the polygon, then what we will do? We will fill up all the neighbors by the red color. So suppose those are the neighbors which are inside the polygon. So we have filled those neighbors, and those three neighbors are not inside the polygon. So these 3 points are not inside the polygon. So what will be the points? What will be the points? So if it is P, the center point is P, definitely suppose the coordinate of the P is xy. So definitely this will be x minus 1, this is the x plus 1, and the bottommost is y minus 1 and this y plus 1. So by taking the different combination of x and y, we can find out the points. So those 3 points are not inside the polygon. So what we will do? We will not color them by red. So in this way, by selecting the points and by selecting the boundary color or by finding the boundary, we can color the entire polygon. So this type of algorithm is called the boundary filling algorithm. Clear? So there are two types of algorithm. First one is the scanline polygon filling algorithm and second one is the boundary filling algorithm. Now we will discuss the scanline polygon filling algorithm. Okay. So what is the approach? The approach for scanline polygon filling algorithm is very simple. I have already discussed you. So I'm consider a figure like this one. Consider a figure. So this is my y-axis and this is my x-axis. So what I will do, I will draw a figure like this one, and then it will be something like this. Then this. Now next, I took another line. And this is the complete polygon. Fine. So this is a polygon which I want to fill. And assume that the coordinates are, we just name the vertex. It will be A, this is B, this is C, D, E, and F. Fine. Now, for the scanline polygon filling algorithm, what we will do? We will draw the scan line. We will draw some scan line which is parallel to x-axis. Okay. So here, consider the y value for this particular x value. So you can consider the y value is y equals to c. So this distance is c. Okay, any constant. And okay, instead of taking c, we take some value. Then it will be easy for you to understand. So consider this y value is 12. So instead of c, okay, so it will be 12 and this distance is also 12. Fine. So what we will do over here, so you can see, so those are the points. If I draw some type, so those are the x value. So those are the x value. So I am drawing roughly. Right. So consider the x value of this particular point is 14. The x value of this point is 18 and this is 24. Okay. So what will be the, so here you can see this scan line intersects this polygon in some points. So it will intersect the edges of the polygon. So the edges AF will be intersected by this scan line at this particular point. Okay, so let us say it is point P1. This same scan line intersects the edges at this point. Let us say it is point P2. It will intersect this point. This same scan line intersect the edge BC, edge of the polygon, and say, let us say the point is P3, and this intersecting point is called P4. So the scan line y equals to 12 intersected the polygon in 4 different points. Fine. Now what we have to do, we have to color only those particular sections, subsection of the segment of the line which is inside the polygon. So from this figure, you can see that from this particular scan line, the segment P1, P2 is inside the polygon. Again, the segment P3, P4 is inside the polygon. Okay. Now the question is how you can find out, how you can determine that which segment is inside the polygon and which is not. Fine. So what you have to do, you after drawing the scan line, you have to find out all the intersection points starting from your left to right. So make it very careful. You have the computation, the calculation of the intersection point is from left to right. Fine. Now after computing the intersection points from left to right, then write down the segment. Take the pair, create a pair. So how many points are there? So there are 4 intersections points. So intersection points are P1, P2, P3 and P4. Okay. So 4 intersection points. Take 2 successively points and form a pair. So what are the pairs we can form? We can form one pair P1, P2, that is one line segment. The second pair is P2, P3, that is another line segment. The third pair is P3, P4. So there is another line segment. So basically there are 3 line segments. One is P1, P2, another is P2, P3, and the last one is P3, P4. Clear? Now, after finding the line segment, what you have to do, you have to remove the next one. So you consider the first one, discard the second one. Again consider the third one, and if there is there is another fourth line segment, then discard the fourth one. Fine. So this first line segment is inside the polygon. The second portion is the outside of the polygon. Again the third portion is the inside of the polygon. Okay. So what we have to do? We have to color the line segment P1, P2 by the desired color through which I want to color the polygon. I want to fill up the polygon. Suppose I want to fill up the polygon by the red color. So what I will do? I will color this particular section by red. Again, I will color the segment P3, P4 by red color. Fine. So I will color the segment P1, P2 by red, and I will color the segment P3, P4 by red. So by using our desired color, we have to color the desired segment. So in this way, by drawing successive line which is parallel to x-axis, you can find out the intersection points. And after finding the intersection points, sort the points, and definitely you have to find out the intersection point from the left to right. After finding the intersection points, you have to find out the pairs. And after finding the pair, you have to take the first pair, remove the second one, then take the third pair, then remove the next one. So in this way, you consider the pairs, and that pair represent one line segment, and color that line segment with your desired color through which you want to fill. Okay. So that is the basic of the scan line polygon filling algorithm. Okay. Now there are some tricks is there for this particular algorithm. Okay. So now see another important shape of the polygon. So consider that there is another important shape. So you consider another shape of polygon like this one. Now we will rename, we will put the name of the vertex. So consider this is the vertex A, this is my vertex B, C. Any order, clockwise or anti-clockwise order, you put the name of the vertex E, F, G, H, I and J. Fine. Now, while you will draw the line, scan line, which is parallel to x-axis, you can find that some lines will pass through the vertex. Okay? So consider a line, consider a line segment. Just a minute. Consider the line segment, this one. Okay. So we consider this line segment which is passing through the vertex I. So let us say for this particular line segment, for this particular scan line, we write the name of the line is y equals to C. So for this particular line segment, this line segment y equals to C intersects all the edges of the polygon and we give some name. So this is the point P1 because this line y equals to C intersects with the line AJ at point P1. This line y equal to C intersects the edge JI and HI at point P2. Okay. It also intersects the line of the polygon HG at the point P3 and this is P4 and this is P5. Okay. Now, if we follow the same logic, that means we find out the points from the left to right. Fine. After finding the points, we have to write down the points in the sorted order and we have to take the pair. So what are the points? The points are P1, P2, then P3, P4 and P5. Okay. So as I told you, you have to take the pair. So you will consider P1 and P2 form one pair. So the pairs which you will form is P1, P2. Next pair is P2, P3. Another pair is P3, P4 and last one is P4, P5. Okay. It will be P4, P5. Fine. So 4 line segment you got. So what as per our logic, we have to consider this one. We have to color this line segment with our desired color. We have to remove this one. Again, we have to color this particular line segment with our desired color and we have to remove this one. If you do so, you can see that P1, P2 is inside the polygon, this particular segment. But P2, P3 is inside this polygon, still we are discarding it. Okay. Again, P3, P4, which is outside of the polygon, but still we are considering it. And P4, P5, we are discarding it. So here, our same logic is not working as this scan line is passing through the vertex. Clear? So, if the scan line is passing, if a scan line is passing through a vertex, in that case, we have to impose some extra condition. Clear? The extra condition is, again, I am repeating what is the problem. Try to understand. After drawing this line segment and after finding all the intersection points, you can see that the line segments are P1, P2, P2, P3, P4, P3, P4 and P4, P5. And as per our logic, we are taking P1, P2, we are discarding P2, P3, we are taking P3, P4, we are discarding P4, P5. So if you can see we are discarding those segments which are inside of the polygon. So we have to add some extra condition while a scan line will pass through the vertex. So what is the extra condition? So if a scan line will pass through the vertex. So here it is a vertex. This one is the vertex. Okay. So if a scan line will pass through a vertex, then we have to repeat the same point twice. Again, I am repeating, if a scan line is passing through a vertex, in that case, we have to repeat the same point twice. So if you do so for this particular case, then what you will get? So instead of those points, what you will get, the intersection points like P1, P2, P3. Okay, so we have to repeat the P2 twice because P2 is the vertex. So we have to repeat the P2 twice, P1, P2, P2. Then we will write P3, then P4, and then P5. So now from those set of points, we have to form the line segment by taking the consecutive pairs. So we will take P1, P2, form a line segment, then P2, P2, another line segment, then P2, P3, another line segment, then P3, P4, another line segment, and then P4, P5, another line segment. Okay. So this is one first line segment, second one, third one, fourth one, and fifth one. So again, as per the logic, we have to consider this one, we have to discard this. Again, consider this one, discard this, and consider this one. So now you can see that P1, P2 is inside the polygon. P2, P2 we are discarding it, but P2, P3 is inside the polygon. P3, P4 we are discarding it, which is outside of the polygon, and P4, P5 is inside the polygon. We are considering it. So what we have to do? We have to color this particular section, those particular segment. That means you have to color P1, P2 by your desired color. Then we will consider the P2, P3. We will color this line segment by your desired color, and then we will color P3, P4, P5 by our desired color. Clear? So this is case 1. So we will consider, we will say it is case 1. Okay. Now you can see there is another interesting case. The same scan line, we will draw another scan line, consider another scan line. Just a minute. Okay, leave it, consider this one. It will be very interesting. Okay, this one. Fine. Now, in this case, first consider this one, then you can understand the previous case also. We have what we have to do? The same thing. Consider that this y equals to C1, the line segment, which will intersect with some points with the edges of the polygon in some points. So let us assume this is P1 dashed, this is P2 dashed, P3 dashed, and P4 dashed. Fine. Now, if we apply the same logic as we have done with the case 1, so in that case, what we will get? If we apply the same logic, okay? So in that case, what are the line segments we will get? We will get the line segments. We first will write down the intersection points, P1 dashed, P2 dashed, P3 dashed, and as I discussed just earlier, if as P4 is the vertex, we have to repeat it twice. Okay. So if I do so, then we have to take the consecutive pair to form the line segment. So we will take P1 dashed, P2 dashed, one line segment, P2 dashed, P3 dashed, another line segment, P3 dashed, P4 dashed, another line segment, and P4 dashed, another line segment. So we have to take it, discard it, take it, discard it. If you do so, you can see P1, P2 is inside. Okay. So here, what you are doing so here you are discarding this particular section. You are taking this particular section twice, which is not required. Okay, you are taking this particular section twice, which is not required. So what we have to do in this case? Here, we don't need to repeat P4 twice. We don't need to repeat P4 twice. We have to consider P4 only once. Fine. We don't need to consider the P4 twice. In this particular example, there is no problem. But if you consider some another example, in that case, you will create some problem. So I will show just a previous one. First, I will discuss this case. So we don't need to repeat this P4 once again. So now the question is, when we will consider the vertex twice and when we will not consider the vertex twice. So you can see for the case 1, see the edges. So the edge ji, the direction of the edge is the as we are traversing the polygon in some order, some anti-clockwise direction A, B, C, D. So if you traverse in this direction, so if you see the y value of this particular vertex and the y value of this particular vertex, so this y value is in decreasing order. Now while you are moving in this case, the y value is increasing. So in a vertex, if the y value is decreasing and for the same vertex and for another edges, so a vertex can be formed with the help of the two edges. So if for one edges the y value is decreasing and for another edge the y value is increasing order, so in that case the vertex should be considered twice. But if it is not like that, so if you consider this particular section case where this vertex D is the combination is formed with the help of two edges. One is CD and DE. So if you as we are traversing in this anti-clockwise direction, so if you see that the y value of this point is compared to the y value of the D point is increasing. So here the y is increasing, and again while we are moving from D to E, again y is increasing. Fine. So if the y value is increasing for both the edges for a particular vertex, in that case we should not consider the y value twice. Again I am repeating, while we will consider a vertex twice when the y coordinate, the value of the y coordinate of two successive edges, if I traverse in clockwise or anti-clockwise direction, then two successive edges, if the y value is increasing, decreasing order, so first one is decreasing, then increasing, or first one is increasing, then decreasing, whatever, vice versa. So if the y value is increasing and decreasing order, in that case, the point, you should consider the vertex only once. But if the y value, if the vertex for two edges, for these two edges, if the y value is either increasing order or decreasing order. So for this particular case, if you traverse in the clockwise direction, then your y value will decrease. If you move in anti-clockwise direction, the y value will increase. So for this vertex D is composed by two edges, and for both the edges, as I traverse in the anti-clockwise direction, the y value is in increasing order. Both all the y values, this y, and this y value of C point, y value of D, and y value of E, all the y values are increasing order. Fine. So if the y values are increasing order, then in that case you should not consider the vertex twice. You should not repeat it twice. So here we will not repeat it twice. We will only consider this part. So if I consider this part, then we will take P1, P2, P2, P3 and P2, P4. So this particular section will not arise. So here we will take this one, discard it, take this one. So if you do so, what we will do? You can see this as we are considering this P1, P2, P1 dash, P2 dash, we will color this part. We are discarding P2 dash, P3 dash, we will not color it. Again, we are considering this one, so we are colored. Fine. So in this way, the y coordinate, we can find out that which particular segment of the scan line should be colored by the desired color of the polygon. Fine. Now next, I will quickly show you how to find out. So here you can see if you can notice one important feature, here our scan lines are parallel to x-axis. That means only y's are just incrementing by 1. So here the y is C1, then next value will be just C1 plus 1. So we should not, so how we can compute the intersection point, that is very important, interesting. So here you can see that we should not compute the intersection point. So here for all points P1 dash, P2 dash, P3 dash, P4 dash, for all points the y value should be C1. Okay, y value should be C1, y value will not change. Which will change? Only the x1. So what we have to compute? We have to compute only the x value. Fine. So now we will see if you can remember that the DDA line drawing algorithm. So in case of DDA line drawing algorithm, as I shown you, that if the y value is increasing, in that case how to compute the x value. So if you can remember the DDA line drawing algorithm, so there you can see that if I increase the y, that means if the value of yk plus 1 minus yk is equals to 1, then we have to compute only xk plus 1 based on the value of xk plus 1 by m, where m is the slope of the line. And as you, so while you are drawing the polygon, definitely you know what are the points, vertex of the polygon. What are the vertex of the polygon? You know it. So from, as if you know the vertex of the polygon, you can easily compute the slope of the line. You can compute the slope of the line for this line segment, for this one, for this one. So you can easily compute the slope of all the line segments. Fine. So here you know that the y value is just increasing by 1. So what we have to do? We have to compute the x value. Fine. So as you know that how we can compute the m? So for any particular line segment, we know the y coordinate, y value. So we can write the, suppose we are computing the slope of the line AJ. So what we will write? So if I move in this direction, that means the anti-clockwise direction. So we will consider this is the first point, this is the second point. So we will write it like YA minus YJ and XA minus XJ. So in this way we can compute the slope of the line. Fine. So after computing the slope of the line, I can easily compute the rest of the intersection points. So as you know the y, as we know the y value, what we have to do? We have to compute the x value just by adding 1 by n. So for any particular line segment, so while you are considering the initial scan line, for initial scan line, that, so for suppose the initial scan line is, for the y value is y0, we assume. Okay. So for this y0, we know what will be the x0, because x0 is the starting point. So if you consider this one, if you consider this scan line, this one, okay, so you know this is the starting point. Okay, so you know what will be the starting point, what will be the x0. So once you know the x0, so if you draw a scan line like this one from this line, so you know what is the x0, right? So if you know the x0, you know the y0, because the line is parallel to y-axis. So what you have to do, you can compute the x1 just by writing x1 equals to x0 plus 1 by m. Fine. While the y value is y0. Now next you will compute the x2. x2 equals to what? x2 equals to x1 plus, as based on this equation, x1 plus 1 by m, and y, the y value y1 will be nothing but y0 plus 1. Fine. Now x3 will be x2 plus 1 by m, and sorry, this will be y1. y1 is y0 plus 1. Okay, we know x0, y0, and based on that we can compute the rest of the points. This is y1, y2, this is x2. x3 is equals to x2 plus 1 by m, and y3 is nothing but y2 plus 1. Fine. Now if you proceed it further, if you proceed it up to k plus 1th term, Okay, so it will be this will be 3 will be replaced by k plus 1. Okay, so subscript will be replaced by x of k plus 1. So what it will be? It will be x of k. So what you can see here, we can write x of k 1 by n. Fine. Now we can replace x of k by x of k minus 1 plus 1 by m plus 1 by m. You can again replace x of k minus 2 plus 1 by m plus 1 by m plus 1 by m. So if you do so, if you proceed further, you can see that this x of k plus 1 will be x0 by 1 by m plus 1 by m up to k terms. Okay. So what we can write in generalized format, we can write x of k plus 1 is nothing but x0 plus k by m. Okay. So this is the equation. By following this equation, you can easily compute the x value, and you can easily you know what is the y value, because we are considering y from the okay. I will tell you the later what should be the initial value of the y. Whatever the y just will be incremented by 1. So y next y will be just y previous y value plus 1. So, and if we know the y value, we can easily compute the x value for any particular age. Fine. So if I know the coordinate, if I know the end point of a line segment, we can compute the m. So for this particular line segment AB, I can compute the m by m slope. Based on the slope, I can compute this one by if I know this what is the number of this line segment. If the number of this line segment is k, then I can easily compute the intersection point, this one. Again, if you know the m value of the line segment FG, so you can know the find out m, and after finding the m, you know this is the kth line segment, you can find out the based on that m, you can find out the x value. And same is true for all the other intersection points. Now, what will be your initial y value? What will be initial y value? That means what is the equation for the line segment? So while you will draw the polygon has a set of points P1, P2, P3 like this one, a set of points, and each point has some xy value. So what you have to do, among all y value, you have to consider the minimum y. Find out the minimum y for all y of the edges of the vertex of the polygon. So a polygon has a set of vertex, and each vertex has a set of xy value. So among all y value, find out the minimum y, and that minimum y will be our starting scan line. That means my y0 will be mean of y. Okay. So in this way, I can find out which will be my starting scan line, and then I can successively find out the next of the next scan lines, and I can find out the line segment, and I can color it. Okay. So this is the scan line polygon filling algorithm. This is all the techniques, all the basics of the scan line polygon filling algorithm. Fine. So I think it is clear to you. So that's all for the today's lecture. Now in my next lecture, I will discuss the polygon filling algorithm based on the boundary. So, and before that, I will discuss some irregular patterns of the polygon. So here you can see in case of scanline polygon filling algorithms, here the polygons has no intersecting edges. Fine. So intersecting edges means like this one. So here the polygon is like this one. Very simple. There is no intersecting edges. But it may be that I can find out a polygon like this one. So here you can see there is some intersecting edges. So if the intersecting edges are there, then the scanline polygon filling algorithm will not be sufficient to fill the polygon. Okay. So in that case, we need some another approach. So that is called the odd even number algorithm or the winding number. So in my next lecture, I will discuss how to fill up the polygons where the lines are intersecting. Okay. So that's all for today's lecture. Thank you for watching my video.